Hello everybody, thanks for joining us. I'm Connell, the CTO here at Zapper, and I'm joined by my glamorous assistant George.
Hi guys, I'm George. I'm a senior product manager at Zapper, and I work with Connell and the team building Mattercraft.
Very good. So I'm going to give you just a very quick outline of what Mattercraft is, but then we'll talk about why it's interesting and why we should be considering using it for our hackathon. We're going to do a live demo as well, so bear with us as always with live demos. Especially we're demoing like AI in it as well, and AI is almost like by definition a random process. So hopefully all is good. So Mattercraft is basically a development environment for the web. So it's a bit like Unity for the web, if you like, and it has fantastic support for AR and VR. Both handheld, but also WebXR for headsets. And of course, that's what we're interested in today. So we'll talk a little bit about what WebXR is and what Mattercraft is. I'll show you a quick set of features, but we'll go through that super quickly because the really interesting stuff is in the live demo. And hopefully it's in the live demo that we will convince you guys to give Mattercraft a shot for your hackathon. There is a separate track for Mattercraft in the hackathon, and it comes with its own prizes and swag, so independent from the other tracks and prizes. So, WebXR, it's a foundational technology, and it is built into the web browsers on headsets. So the browser on Quest has WebXR support. The browser on other headsets like Pico and Magic Leap and Vision Pro all support WebXR. And it enables web pages to provide an immersive interactive experience. So obviously a web page is normally just like a 2D thing that you can scroll. With WebXR, you hit a button and you can go into a fully rendered 3D environment that could be virtual reality or mixed reality. And we'll see how all of that works. This is a little video that just shows Mattercraft. It's supposed to sort of tease you into giving your attention to the rest of the talk, but don't worry, it goes by quickly. We'll be going over it all when we get to the demo. It also has music, but we elected to talk over it instead of play the music. So as I mentioned, it supports a ton of different headsets. It comes with a set of templates, which we'll see, and this is one of the templates being shown. Of course, it supports hand tracking and controllers. It supports animation, live preview, which has like a ton of great features that we will see in action shortly. You can have simple interactive games like this mole-based experience all the way through to complex gameplay experiences, stateful experiences. We'll talk about how that type of thing is built in Mattercraft. A ton of different features. I have now mentioned them already. And so we can basically just go to the next slide. Next slide. So, what is the benefit of WebXR versus a more traditional, like Unity-based development cycle for a headset? Well, the first and most important one is WebXR, because it's an underlying specification. You can build WebXR content once, either handwrite it, or you can build it with a tool like Mattercraft, and it will run on any device that supports the WebXR specification without you having to like rebuild or recompile or change plugins or anything like that. So you build once, when you publish, it becomes a web page or a web URL, and that URL can be launched on Quest, Pico, Vision Pro, you name it. WebXR is part of the web ecosystem, and you may know that there's a huge community and ecosystem around front-end web development. And so when you're building for WebXR, you can leverage that ecosystem. So there are huge amounts of resources online for building 3D content for the web, and they all apply when you're building WebXR content. Because the content is a website or a web page that you're publishing, there's no App Store submission processes. So once you've published your content, you get a link or a QR code that you share to your users, and they can access that straight away. And you can publish updates to that content just by hitting a button in Mattercraft. There's no, submit it to the store and wait for an approval to happen and then it become live. And there's no need for the end user to go to an app store to find and download your application, as it just launches in the web browser on their device. So it's like super fast for them to get into that experience, and they're not there having to download, 500 megabytes plus of app just to have the experience you're building for them. So enter Mattercraft. WebXR is a specification built into the web browsers, and that specification is exposed as JavaScript APIs in the web browser. And if you're like me, I'm a coder by heart, but I also don't like coding to describe like 3D experiences and 3D scenes. That gets tedious very quickly. And so Mattercraft is a tool that leverages all of the great web ecosystem that we've talked about, that you can absolutely script in, and we'll see that in the demo, but that provides a full 3D development like UI so that you can build the 3D bits of your experience using the types of tools we're familiar with in things like Unity or Unreal, where that doesn't normally exist in the front-end web ecosystem. So Mattercraft, if you like, is the love child of the web ecosystem and the kind of tooling you get with Unity and Unreal and these big game engines. So there's a ton of great features in Mattercraft. I will put this on screen and let your eyes dot between the items. So I won't go through them all here because we will see these all in the live demo. Suffice to say, it's proper. Like, it's not like it's some of the web tooling for 3D is a little bit kind of, you know, it was made by somebody in their pants at the weekend. That's not what Mattercraft is. Mattercraft is a proper, fully fledged development environment for content, and it's featureful and rich. So we'll see those in a minute. So, of course, I mentioned it has headset support. Mattercraft in general is just a 3D development environment. So just like you can make games that don't involve XR with Unity, you can do the same with Mattercraft. So Mattercraft supports, you know, web browsers running on laptops and on mobile phones, as well as headsets. But of course, the purpose of our hackathon is running on headsets. And of course, I imagine you'll all have Quests, and content built with Mattercraft runs perfectly on Quest. And my good friend George here will be demonstrating Mattercraft's output on a Quest that we have brought for this very purpose. So WebXR, the underlying specification, is really quite bare bones around the tracking technology and the displays that are in headsets. So it doesn't provide a ton of the things that you get for free in something like Unity. And so with Mattercraft, we add to the WebXR specification, or if you like, on top of the WebXR specification, all of those bits that you need to make a proper XR experience. So things like teleport controls, so that the user can navigate around within an experience. Things like input normalization. So if you want the user to like point and click on something, Mattercraft gives you the ability to expose that functionality without you having to work out, well, on Quest, it's like 2 controllers with the triggers, or maybe it's point and tap if they're hand tracking, or if it's Magic Leap, it's like a single doodah button thing. All of these are abstracted. I mean, you can use all of the inputs of the buttons if you want, but Mattercraft gives an abstraction there that means you can build once, target all of these devices, and know that the click event will be mapped to the most appropriate thing on a given device. There's other things that we do to smooth around the differences between different devices. So, for example, Apple Vision Pro doesn't support the mixed reality mode, where you see the camera as well as the virtual content. And so we do some things to make sure that mixed reality mode content doesn't break on Apple Vision Pro. And so, you know, in addition to the input techniques, we do a ton of things. We've just tried all of the devices and done everything you need to do to make sure it works. There are full animation primitives built into Mattercraft, so that's timeline-based animations with keyframes. We have a state animation system as well that allows you to build animations that automatically tween between different states for the properties of objects. The reason I think it's really important for the work we do together over the next couple of days is that you can actually build quite a lot of the state of your experience in the animation system, and that means it's entirely previewable and interactive in the editor, so you can do a ton of your design work without having to be constantly pulling the headset on or off or what have you. And Mattercraft features a real-time, always-on live preview. So if any of you have ever done any front-end web development, you might know of tools called bundlers, like Vite or Webpack or Parcel, these sorts of things. In the front-end web development ecosystem, they're tools that constantly compile your web project as you're working on it, so that in your web browser, you can see the effects of your changes as you're working on them. Mattercraft has exactly the same kind of technology built into it, where as you are editing and building in the editor, a always-on available live preview is accessible of your project. And we'll see this in the demo. I'll be able to work with and edit the project as George is wearing the headset to try it. So there's a really tight iteration between making changes and seeing the outcome of your efforts. There is, of course, scripting in Mattercraft, and it's based on the web browser APIs. It is the web browser, after all. So you can script in Mattercraft with JavaScript or with TypeScript. We provide a scripting editor built into Mattercraft, which is built on the same code editor that's in Visual Studio Code. So it's like super familiar, and it's got all of the things you expect in a script editor, like autocomplete, constantly checking and underlying any mistakes or errors, that sort of thing. It's also possible to live debug on your device, so you can connect your Quest and use like Chrome debugger, which allows you to add breakpoints to your code and step through everything that you would expect if you were, trying to work out why your code wasn't working on the device. And we've also just released a fully integrated AI assistant into Mattercraft. So if any of you have used like Cursor or Windsurf or Copilot, these sort of new generation of AI assistance tools, we have built that technology directly into Mattercraft. There are 3 modes. There's an ask mode where you can just ask questions, and we've prompted the AI system with lots of knowledge about Mattercraft. So it's great if you're coming to it as a new tool, it can answer your questions. The real value add is edit mode though. It's the mode where you can vibecraft. You see what I've done there? You can vibecraft and have an active conversation with AI assistant, and it will propose changes to your project that you can accept or reject. That can go all the way from asking it to build an animation. Mattercraft's AI assistant knows how to propose changes to the animations and the 3D structure of your scene, all the way through to asking it to build complete custom components, and it will create full scripts of the component that you want it to build. Well, that's what we're going to do a live demo of today. You can even do things like drag in a Unity shader and say, convert this into 3JS, which is the underlying rendering engine in Mattercraft, and it will just happily read your shader, understand how it works, and then rewrite it as GLSL in a custom component for you. And then finally, there's autocomplete. It's just like as you're typing, provides intelligent suggestions for the code to follow your cursor, much like something like Copilot does. You can often just write a comment, and the suggestion that it will make will implement what your comment says. So it can be like a little block of code, or it could be an entire function. For the most part, it makes really intelligent and sensible autocomplete suggestions for you. So the AI assistant is in beta in Mattercraft at the moment. So if you would like to use it, just drop us a note on Discord. We will activate the AI assistant for your account, and we'll also give you a complimentary bundle of credits so that you can be using the AI assistant with abandon and not be worrying about the credits and all of that stuff. So just let us know if you'd like to use it. I would highly recommend, if you were using Mattercraft, to give it a try, because it's like having one of us sitting next to you as you're building. All right. Shall we just go into the live demo? Okay, cool. So I will switch to Chrome. Oh, this is Chrome. I will close that. I'll switch to this Chrome. So Mattercraft itself is a web application. So and I'll give you the details about how to access it in the slides after the demo, but it runs in your web browser. It is literally 1,000 times lighter than Unity in file size. So if it's 3 gigs to download Unity, it's 3 megabytes to open Mattercraft in your browser. So it's super lightweight. And what we'll see is Mattercraft builds and downloads the dependencies depending on what your project uses. There's a ton of different templates that Mattercraft has that you can choose from. Of course, the headsets and VR section is where we're at. There's a set here for VR starting off, MR with pass-through. There's a user placement template, and there are some physicsy, grabby ones. Which one do you want to go for, George?
I think we do the physics.
The physics of the hand grab or the controller grab? Controller grab. We'll go controller grab. Okay, cool. So yeah, every template has a little bit of description and a list of supported devices and what have you. Let's just get started. So Mattercraft, as I say, is built on the web ecosystem. So if you have any experience, and I should say you don't have to have web experience to use Mattercraft, but if you do, there are a ton of concepts here that you'll already be familiar with. So when you're building a project with Mattercraft, it's built on top of NPM, the big repository of JavaScript libraries. I will, in the kind of showing you and demoing of Mattercraft, I'll show you the places where Mattercraft and the web ecosystem are together. If those bits don't mean anything to you, that's absolutely fine. You can do like most things in Mattercraft without having to have any knowledge or experience of building a website. So I've loaded this experience. We have a set of files on the left here. This is the project tab. It just shows you the files that are kind of relevant to the creative process. If I go to this All Files tab here, you can see there's actually lots more files in your project. Things like node modules, which if you're a web developer, you will know, package.json, etc. Most of the time, you can just hang out in the project tab. It hides all of the files behind the scenes that make your project work, and just shows you the ones that are relevant to you in the creative process. In the middle, we have a 3D view. This has got the scene.zconf file open. It's like the root scene of your Unity project. And we can see here it's got our controllers, it's got some boxes. And then on the right, we have the hierarchy, which is akin to the hierarchy in Unity. And we can see that there's the VR rig with the various controllers referenced, the camera, some bits about the environment and the view that we provide to the user. And there's some physics elements in this experience as well. We can select a given object, of course, and there's the usual set of properties that you get when you select a node like you would in Unity. We have a behavior system that allows you to attach additional functionality onto items in your hierarchy. So you can attach things there that will bind to the click event and play an animation, or bind to, I don't know, a collision event and do some other activity or what have you. And in Mattercraft, you can write your own custom components that appear in the hierarchy, and you can write your own custom behaviors for you to attach wherever you like. And in a moment, hopefully the AI assistant will, this is not the AI assistant, this is the natural assistant. Glamorous, sorry, it was glamorous. This assistant's also quite glamorous, George, I'm sorry. So the AI assistant will write a custom component for us shortly. But first, why don't we take a look at the live preview? So Mattercraft has, as I mentioned, this always on live preview that you can use to access the experience. If it's a handheld experience, or you just tap the live preview button top right here. If it's a handheld experience, you can just scan the QR code. But obviously in this case, we're using the Quest. And so we want to send the URL for the live preview through to George's headset. And there's a launch on MetaQuest button here. If I tap that and the Wi-Fi works, it will allow me to open this URL on that Quest headset. So this requires that you're signed into the headset on your Meta account on the headset and your Meta account on your laptop. There's another way. If you're using a device that doesn't have your account signed in, there's another way of doing it, which we'll talk about later. Suffice to say, the easy route, the easy path is if you're logged in, you just hit launch on MetaQuest. And I will press open here and then very quickly go to the casting tab. Oh, which George is... No worries, he's on. I think we're still ahead of somebody installing Unity for the first time. Cool. Okay, so here's George. I'm going to go back to this URL here and just go open. And what that will do, if we swap back here, is it will open that as a tab in the browser on his device. So we can see that there. Oh, let me just look down a little bit so that we get all of George's action here. There we go. And so this is the splash page for experience. This is exactly what we've just been doing. And then when George taps launch there, we enter into this experience. And in this case, he's throwing boxes around. Yeah, cool. If you could look maybe directly at the boxes. Well, there we go. All good. Nice. So this is obviously a VR experience. It would be more interesting if this was a pass-through experience. So let's go back to Mattercraft and just make a few changes that enable that pass-through. The other template, the pass-through template, has those changes already, but we started with a template that was VR. So let's make that change. So I can do that by going in here and going to our XR rig, XR manager here, and select immersive AR. That's the specification in WebXR for showing pass-through. And I'm going to delete the sky environment because we don't want to be rendering the sky just over the camera. So if I make those changes, I'm going to save the file. I pop back to the casting, and it automatically reloaded this for George. And then here we are now, mixed reality with the objects. Cool. Okay. So one thing I'm going to do is I'm going to add another non-physics box into the experience. And then what we'll hopefully be able to see is we can work with that box, change its size, and those changes will take place in real time for George. So we have a really tight iterative process. So I'm going to pop back to Mattercraft. Just in the root of this project, I'm going to add a mesh, a box mesh. Here it is. I'll just put it forward a bit and up a bit here. And what I'm going to try and do on this small screen is a little bit of view jiggling so that we can see at the same time what's going on. You can hide these little sidebars as well. So we can see the casting happening at the same time. All right, so here's the box, and as I scale it up and down, we can see in George's environment that change is happening in real time. So it's great for sizing of things or getting the right feel, because obviously when you're not wearing the headset, it's kind of difficult to get the feel for how big something is. And so this type of change is perfect to do in that manner. Great. Okay, cool. So shall we choose your own adventure animation system or AI? We do hands up.
Can do.
Hands up, who would like to see the AI first, and who would like to see the animation first? Oh.
50-50.
50-50. Cool. Well, why don't we show the animation system super quickly, and then we can pop to the AI assistant. The AI assistant can use the animation system itself as well, which is kind of interesting. So there's this animations tab down at the bottom, and in here you can add timelines and states. And there's this concept called layers. Effectively, you use a layer to separate animations that are independent from each other. So it allows you to have multiple timelines that each do different things to different objects. So I'm going to create a new layer, and in that layer, I'm going to add a timeline. And in that timeline, I now get a full, I'll collapse this as well, give us a bit more space, full timelining tools. So I've got my box selected. I can add the rotation of the box to the timeline. And then let's say a couple of seconds, I'm going to rotate that box round by some degrees. And then I can play that animation and it works. And so you can build obviously really quite intricate experiences just with the animation primitives. So I can add multiple things to this same timeline. So other objects, other properties, pretty much any property that is of an object in the hierarchy can be on a timeline and can be animated. Then let's say I wanted to play that animation when the box was tapped. Well, I could either write a script to do that, or I can just go to the behaviors and I can say animation actions, play layer clip, select on click, and then I can select that timeline I created. Then when that experience is played, if George points and clicks on that box, that animation will play. So straightforward, simple but powerful animation system. Cool. Okay, not too much of a diversion before the AI assistant. Nice. So I'll delete that box and the layers. So, the animation assistant is, you may recognize this as being the universal icon for AI. This is the AI assistant top right in Mattercraft. There's two modes, as I mentioned, ask and edit. And in the ask mode, you can just ask general questions about your project. So give me a summary of this project, for example, is one of the provided options, but I could obviously just type in my question here. The AI assistant can open the files in your project to understand what's going on, and then, of course, summarize. Because Mattercraft is built on top of the web ecosystem, there's a ton of the ecosystem in the training for the AI model, right? So the AI assistant is built on top of Claude 4, which is like the latest model from Anthropic. And Claude is trained with like a ton of 3JS knowledge and a ton of web ecosystem knowledge. And so while we've given the AI assistant a ton of Mattercraft specific knowledge, it actually knows a lot just generally about how to build this type of experience. And so you'll, I hope, find that it can be very knowledgeable and helpful. But let's go to the real meat of the AI assistant, which is edit mode. So in edit mode, it can propose changes to your project. So for example, I could ask it to have created that animation. I could literally say, create an animation that rotates the box and play it when the box is clicked. And the AI assistant will open this file. It will see the presence of the box. It will, I mean, in this case, there are other boxes, so it might even ask us to clarify which box we mean. And then it will create a new layer, create a timeline, go through exactly the same process that we did, and it will present that all in a form that we can accept or reject in the project. So we can say, oh, I like the changes it's made to the timeline, but I don't like the changes it's proposed to the behavior. I want to do that myself, and I can do that. Or I can ask it to further make changes and say, the behavior was fine, but maybe do it like this. Then the AI assistant can further revise those proposed changes for you to then accept or reject at your pleasure. At your leisure. Pleasure, leisure, both. Cool, okay. But let's give it something a little bit more meaty than that. So in Mattercraft, as I mentioned, you can write your own custom components. So Mattercraft has got this component model. It's a bit like React or Angular in the front-end web development ecosystem. A component is basically a class that has inputs, and those inputs are in fact what you see when you select an item, in the hierarchy like this. These are the inputs to the component. And it has like an output, which is, I suppose in the web world, it's normally like an HTML element on a page. But in Mattercraft, it's typically a 3D object or a 3D concept. So box, for example, is a component that wraps around a box, a 3D box from the 3JS library, which is, as I say, the rendering engine powering Mattercraft. And you can write custom components by writing these classes. And you can do so by just creating a new custom component here, for example, from the plus menu. But we're going to ask the AI assistant to do it for us in this case. So I'm going to ask, create a custom component that's a dance floor. And we'll submit that in. And in the AI assistant, so in edit mode, it uses a slightly heavier model than the ask mode. So it'll be a little bit slower, but for the most part, it'll be pretty good. So it's opened the scene. It understands what's going on in here. It's going to create a new file for us. It's created dancefloor.ts, so a TypeScript file. Why don't we have a little look at that? You can see this is a custom component that it started to write for us. It's just got a sphere geometry object in it to begin with. But what we'll see now is that the AI assistant will start proposing changes to this script file to implement the dance floor. It might take a second at this moment because it is coding. It would take me longer, I think, to write a dance floor. I would be deciding what color it would be still. So we'll give it a second. While that's happening, what we'll see is that this proposed changes to the script can be accepted or rejected. So here we go. It started proposing changes into the script file, and each set of changes can be accepted or rejected like this. So if I like them or I don't like them, then I can accept or reject them. And I can accept or reject the changes as a whole in here as well. So it's proposing these changes. It's added them. Let's go back to our scene. And it looks like it hasn't added it to our scene yet. So I'll just say, add the dance floor to the scene. So the first thing it does is request from Mattercraft the set of available components and behaviors, which now includes the dance floor that it's created. And with any luck, it will now add it to the scene. It's also going to give us some settings. There we go. A nice new age dance floor with some animated tiles and what have you. So we can see here that in addition to writing the custom the code for implementing that custom script, it's also given us properties that we can edit in the view. So whenever you're writing a custom component, you can have a variable, much like you could in Unity, and you can say, I would like this variable to be editable in the UI. And then there's a ton of configuration options for saying I'd like it to be a color, I'd like it to be a slider, these sorts of things. And indeed, the AI assistant, even without us prompting it, knows that those will be useful for us, and so builds them. So the base color, for example, we can switch out. So I don't know, we can go for a green. Nobody likes a green dance floor. Blue. Blue was good. It made a good first choice. And then, of course, there's a ton of these other settings and opportunities for configuration. If we wanted to say, let's say actually, make it multicolor, aka rainbow, and it can handle British spellings of words as well, like color. Interestingly, though, it can also work in other languages. So if you want to for it to work in your own language, then just say at the top, I prefer to. Ich spreche Deutsch. Können wir in Deutsch machen es? We can ask it to do things in German, and it will respond and have that conversation with you in that language. Cool. Okay, so it's made some changes here to swizzle it into a colorful setting. Do you want to dance on the dance floor, George? No, probably not. Cool. In any case, it's a great opportunity to learn about Mattercraft as well as obviously being useful for building stuff, because you can then go in and you can see how the AI assistant has implemented that component in order to then further modify it or just to understand how it's put together. Much like tools like Cursor and Windsurf, the code the AI assistant produces is all trained from the code of people on the internet many years ago up until recently, and so maybe of variable quality. But in general, it's pretty good, and as you can see, it gets the job done. Sometimes it will make mistakes when it's coding, much like any of us do. But when that happens, because Mattercraft is constantly compiling your project, Mattercraft can tell when there are errors, much like when you get a red underline in the script editor. And in that case, every time the AI assistant proposes changes, Mattercraft gives it the opportunity to fix errors that have been detected. So even if it writes broken code to begin with, it will automatically say, oh, I see the mistake I've made, I'll fix that. Likewise, if you're coding and you don't know how to fix an issue that is appearing in your script, you can just ask the AI assistant, fix my code. It will look at it, gets the same list of issues that your project is showing as you do, and then it will either propose the corrections, like with this mechanism, or if you want in ask mode, it can just tell you about the issue and help you fix it yourself, whichever you would rather. Cool. Anything else to demo right now? Or shall we get back to the less exciting slides? Back to the deck. All right. We will, of course, have time for questions, I think. Possibly. Hopefully. But for the moment, let's pop back and do some of the kind of more housekeeping bits. Nice. So Mattercraft has support for a ton of different assets. Of course, GLB is Mattercraft's favored format for 3D models, if you like. There's great exporters for Blender, for GLB, and then you can find GLB models in a ton of places like Polyhaven or Sketchfab. There's also some great like text and image to 3D tools for GLB. There's one, we'll probably put it in a little pack on Discord. Meshy.ai produces pretty good GLBs. So you can just literally go in there and upload a photo of a chair, and it will produce a 3D model that approximates the chair. Yeah, support for the kind of usual other sets of things. Quick reminder that the benefit of WebXR, as we've seen, is that it can be really fast for your users to get into an experience and access your content. And for that reason, content built with Mattercraft and with WebXR is great for the kind of shorter form type experiences. So whereas in Unity, it makes sense that you could have, massive sprawling environments that end up as, 500 plus, gigabyte plus downloads or APKs for your users. In Mattercraft, because it's loading in the browser, try to keep your experiences more short form. And I suppose, don't be putting like 500 megabyte GLBs in, basically is what I'm saying, because your users are going to be sitting on the browser waiting for it to load. So we recognize that it's a new tool for most. And so start with something simple and build out and add complexity as you go. And of course, the AI assistant can help you do so. Keep the interaction simple and familiar. Avoid having to teach users new user interface paradigms, because it might be one of your users' first VR experiences. And so, yeah, just keep it simple, silly, rather than stupid. Opt for smaller environments and 3D models, as I mentioned, because size matters on the web. And simple animation and sound go a long way to make an experience feel premium. So even just adding some ambient music or some animation to the experience can really make it feel alive. Okay, if you're ready to get started, you can head to Zap.works. So Mattercraft is one of a set of tools that we provide through our ZapWorks platform. Head to Zap.works and you can register for a trial. As I say, tell us your email address and your ZapWorks workspace on Discord, and we will activate the AI assistant feature for you and give you a ton of AI credits. If you run out of AI credits, just let us know, and at our discretion, we will apply more credits to your account. I think you get 1,000 by default, which is pretty decent. So, Mattercraft, there's two ways you can work with a Mattercraft project. You can create a cloud project from Zap.works. That is a project that's hosted in the cloud, and you can have multiple users editing that project in real time, kind of Google Docs style. Or if you're like me and a bit more like of a coder and are used to like revision control, like Git, then you can also open just a folder on your computer in Mattercraft and work with the files in that folder, and then commit that to GitHub and GitLab or whatever your revision control system of choice is. All of the scripts and the ZComp files that we showed, that 3D scene format, all merge pretty readily. But if you are using revision control, as always, communicate well to avoid merge disappointment. But to access a local folder, just head to app.mattercraft.io in your browser, and that shows you a little view. I can just show that here. If you just go app.mattercraft.io here, then you can open a project from your computer and then just create an empty folder with a name that you can easily remember, like and then you're in. I'll just literally choose one and then open that folder so you can see what the files look like. Where can I find documents? Zapper. That'll be it. I think I created it inside the project. That could be anywhere. Here. Yes, here it is. So this is what a folder of Mattercraft files looks like. Like there's that scene.zcomp file, the package.json, basically the same set of files in here, but obviously it's stored on my local computer, so I can commit it to Git. I can do whatever I want with it. Like if my heart desired, I could open this in Visual Studio Code and edit it there as well. Nice. When you're happy with your experience, you can publish it through Zapworks. So there's a little publish tab in Mattercraft, and when you click that, you can hit publish. It will give you a QR code and a URL, and any end user that visits that URL in their Quest browser will get access to your experience and will see it. If you want to make changes, you just go to publish and publish your changes. You can see the little version history of your different publishes. So just super quick, like Mattercraft will recompile your project in like production mode, so it's all minified and compressed and stuff. But within a couple of seconds, you can be deploying updates and publishing new versions of your project. It's exactly the same QR code and URL for the users regardless of the version. So if you just distribute your QR code once or your URL once, and your published updates apply to whomever next scans that. I mentioned already that if you're logged in on your Quest, then you can use the Launch in MetaQuest button inside the live preview to launch directly, easily on the Quest. If not, there is this website called hmd.link. It's a really useful site. You visit it both on your laptop and on the headset, and allows you to just share URLs between the two. So you just grab the live preview URL or a publish URL for a Mattercraft project, go to hmd.link and paste it in there. Then on the headset on hmd.link, you'll be able to see it and tap on it and launch it. So you're not there having to be like HTTPS switch page, switch page, / etc. Much faster. We have a documentation site with a ton of stuff. Obviously, the AI assistant is relatively knowledgeable. We've got some tutorials online, and we will be hanging out on the Discord and IRL in the mentor room. Mattercraft, at the moment, because we use that file system API for opening projects on your folder, it's supported by Chromium browsers, so Google Chrome or Microsoft Edge, and of course, like Mac, Windows, Linux, you name it. If it's a Chromium browser, you're good to go. Sadly, no love for Firefox, even though that is my preferred browser, but Firefox doesn't implement the API. Cool. Okay. I think that is a whirlwind tour of Mattercraft. If there are any questions, let us know. Thank
you. If I want to use my own bytecode tool cursor, is it possible to use that with the local files and use it with Claude, Sonnet, or whatever? Yeah, absolutely. And indeed, it was because people were doing that with Mattercraft that we built the AI assistant in the first place. So you can absolutely do that. It is Claude Sonnet 4 that we run in the AI assistant edit mode. And the benefit of the integration there is we prompt in a ton of Mattercraft knowledge. Plus, we also give the AI assistant functions to call to get things like the TypeScript errors, the list of available components, and the functions for proposing changes to the 3D scenes. But you are very welcome to use your own vibe coding tooling of choice, if you wish.
Is there support for the camera pass-through API for the MetaQuest 3?
So the pass-through mode of WebXR is supported, so it will show the camera. But I don't believe that the Quest browser provides camera frames. So accessing the actual frames from the camera, I don't believe is possible, much to our annoyance, because we have asked. We want to do a ton of cool things in WebXR that we also do on mobile handheld, like VPS, so fully localized to a real-world environment. And in order to do that, we need to run our own computer vision on the camera frames, which we can only do on handheld at the moment.
Thanks for the presentation. I'm an Unreal Engine developer. It's like a new territory for me. Does WebXR support, or does it have some dependencies for image tracking? And the second question is, I forgot that one. I'm not the first one.
No worries. WebXR as a specification does have support for image tracking, but I believe it's only implemented on handheld Chrome. So I don't think the MetaQuest browser supports image tracking. Mattercraft as a platform has image tracking samples as well for handheld AR experiences, which you're of course welcome to try, but I think the scope of the hack is headset based rather than handheld.
The second one occurred to me. So, I was wondering if there is a way to find a hack around this limitation, or it's not a limitation, maybe your design objective to make it very short experiences and the package size very small. Can you hack this into a system where you chunk, basically, so you have the user download one chunk of the experience and then go to another room, download that chunk as well?
Yeah, absolutely. And in custom components in Mattercraft, you can use just the normal browser fetch API to download 3D models or what have you. All of that's possible if you want to implement it yourself. The other thing you can do in Mattercraft is when you import a script file, in JavaScript there's a typical import yada from yada.ts. And if you do that, it gets bundled into the root JavaScript file. But there's an asynchronous version of that where you can go await import brackets and the name of the file you want. And then whenever you call that, gives you a promise that resolves after that has been downloaded. And so that allows you to even delay until you want it to happen, the downloading of script and other things. In Mattercraft, there's that scene.zcomp file that we saw. That's just a 3D scene. And much like in something like Unity, you can create as many different scene objects as you want, or components like that as you want, that you can work with in the editor. And so if you wanted to, say, have a scene that only loads in when a button's pressed or when the user reaches a physical location, you can just create a custom component that does that await import for that scene. And then when that promise resolves, you can just add it into your project. So you can definitely get around that if you like. Just my advice generally is when you're targeting the browser, you're also targeting an expectation from the user a bit, that it's a shorter form or lighter experience.
Thank you for an interesting presentation and amazing product. Can we import animations and components into our development environment, like VS Code? I tried that, and it was basically there was only one file, and I could not really make sense of it. So how is that possible?
Yes. So you can always open your Mattercraft project in Visual Studio, and in there you can be working with the script files, the HTML files, etc. The 3D scene, that scene.zcomp file, it's a little JSON file that describes the hierarchy and these sorts of things. And so when you edit them in Visual Studio Code, they'll appear as JSON. When it comes to compiling or building your project, you need a bundler that knows what those zcomp files is. And so we provide a package that you can use with the parcel bundler, which is just a standard JavaScript bundler for compiling your project. Have I answered your question correctly there?
To give you a bit of more context, I have an already existing project. Mixed reality part is in 3GS. And let's say I want a certain component created in Mattercraft. Let's say I make it and I want to export it, and I want to export it in VS Code in my own development environment, in my own code. Like I just want to export a simple part. Is that possible?
Yes, I think so. It's not the standard way that people use Mattercraft, but I think it is possible. What I think you would do is in Mattercraft, you would actually compile your project, and that gives you a JavaScript file that then you would just add to your existing project. And in your Mattercraft project, you'd export a function that you can use for initializing the scene. Mattercraft, in addition to the components being 3JS, also provides quite a lot of the kind of bootstrap and structure. You know, it creates a canvas, it sets up the WebXR renderer and the WebGL renderer, and configures 3 with kind of modern settings like physical lighting and tone mapping and these sorts of things. And so those are the kind of bits that you would miss. But if you'd like one of us can come and kind of see if we can get it to work with you, basically. I think it should be possible.
I have a question. The question is, like, we've seen the AI tool you've just shown. Where are the limitations for that?
That's a good question. I think that, unfortunately, my answer is going to be a little bit wishy-washy, I think. The first thing to say is it's actually surprisingly effective. It's surprising the types and breadth of the things that it can do. Certainly, it's surprised us. And a lot of it comes down to just these great models like Claude from Anthropic. But of course, we've worked really hard to make it work in Mattercraft. So what we've given the AI the ability to do in Mattercraft is it can read the files of your project as it chooses to understand how your project works. And then it can propose changes to add elements to your 3D scene, to remove them, to change the properties of them, to do the same with behaviors attached to the objects, to add and modify animations in the animation system, and then to propose new files and changes to text files, and it uses that to obviously do the scripting and what have you. It is pretty good at mapping, like we did with the dance floor experience, a relatively non-specific general request into something that then works in Mattercraft. But the better you can specify for you what you want, the more likely that AI will get it right and give you something that is sensible. And the more likely it will be to ask you if it's uncertain about these sorts of things.
Can I give an example? For example, if I have like a block out where for like a game, and I want it to look now like a castle. Like would I have to tell it for each object individually? You have to put up a floor there. You have to put a ceiling there, or could it do it everything on its own?
I see, yes. So it can do simple geometric things like the dance floor, for example, or like walls or these sorts of things. But it fundamentally, it doesn't in its mind have a picture of your scene. Although you can actually take a screenshot and drag the screenshot into the AI assistant. So you can, like, one of our tests is like make a procedural tree, and it will write a custom component that builds a procedural tree. And sometimes the leaves are not connected to the tree or something like that. And you can screenshot it and then put it in, and it'll be like, oh, I'm sorry, I see that the leaves are not connected to the tree. I will change how I do it. Sometimes it's like, what a beautiful tree. But for the most part, it does well. But in general, it doesn't have a concept really in its mind of the physical space. But it has an understanding of how the concepts in general relate. So for making something like an environment like that, what I would recommend to do is get a set of 3D models and assets associated with what you're trying to achieve. So if it's a castle, for example, you're getting chests and swords and these sorts of things. And you can just drag them into your Mattercraft project. You could use generative AI to make the 3D models, like Meshy, if you wanted, for example. And then whenever the AI assistant is responding to your query, it can see a list of the 3D models in your project, and it can actually also get the metadata for those models. So it knows like the animations in the model, for example. And then you can be like, well, I think one of the ones you have done in the past is like make a pirate shipwreck, yeah. A pirate shipwreck. And then it'll just be like, oh, I'll put the island here, and I'll put the chest here, and I'll put some trees here. And I'll just use the assets to build the scene. You can also, like, if you've got 20 objects in your hierarchy and you want to make a single change to all of them, first of all, I mean, you can multi-select them all in Mattercraft, and then edit the property and it will apply to them all. Or you can just say to the AI, make a change to all of these. And what the AI typically does is like chunk them up and do, oh, I'll just do 10 and then it does it. And then I'll do another 10 and it does it, etc. So you can just ask the AI to do things that are laborious otherwise, for sure.
Okay, thank you.
Hello. I would like to make a tech demo, but that requires me to modify the input of the control system because you have a default like grab and teleport. How easy accessible is it to either modify, hijack, or rewrite that system?
Yeah, well, there's a couple of options. There is just events in Mattercraft for all of the different typical types of input that you get. So like A buttons, B buttons, etc. And of course, the positions of the controllers in space. All of these things are typically accessible. But the other thing that in Mattercraft you can do is components have this fork option. So if there's a component in the hierarchy that you like, but you want to modify, you can right-click in it and go fork. And Mattercraft just grabs the source file, the source TypeScript file for that component, puts it into your project as a new file, and then makes that item in the hierarchy point to your fork. And then you can just go in and start editing how that implementation works.
So grab in teleport are two separate packages you can individually fork?
Yes. So I can maybe show very briefly. If we pop back to Mattercraft here. Oh, that was the other one. Did I keep the... Yeah, here we are. So I think this one has, I'll just accept all the AI changes and thank it for its service and hide it. So Teleport Manager here, for example, is the component that allows the user to move around in space. And if I want to make changes to that, well, first of all, I can right-click on Teleport Manager. I can say open source file, and that will show me how that is. But I can also go fork component. And then when I hit fork here, that will give me a Teleport Manager fork here. It's updated that component to use the fork. And then I can go in here and I can just see how that component is implemented. And I can make changes. I mean, this one looks complicated on the outset, but it's probably not too bad once you get into it and start reading it. But in any case, most of the functionality in Mattercraft is easy to modify in this manner. Like you can start from the existing component. It's all designed so that everything still works the same immediately after the fork, and then you can do the changes that you want.
So does this support API calls or maybe MQTT or maybe TCP IP or BLE integration?
Yeah, so you can do pretty much anything that you can do in a normal web browser in Mattercraft. And so the typical web APIs are fetch, that's just a normal HTTP or HTTPS request. You can use WebSockets, which, like Datagram, you can just send packets of data. There's a really great project called Peer.js, actually, which you can just add. It's a NPM dependency, which means you can add it to Mattercraft from the dependencies browser. And it lets you do peer-to-peer networking between different devices, and it just gives you this message channel that you can share between them. So there are those options. I think with WebRTC, you can do things that ultimately map down to UDP, or maybe is a protocol that's slightly more reliable than UDP, but not as slow and crappy as TCP, so somewhere in the middle. And that API is what's used for the video conferencing and these sorts of things in the web, but you can totally use to do kind of lower latency networking. WebRTC is how the live preview in Mattercraft works, for example. And then on top of that, you can, those are the primitives, if you like, and you can build whatever you like on top. What you don't get is just a socket. The web browsers don't provide just a very basic TCP IP or UDP socket. But on top of that, there are those web APIs which simplify, but also abstract.
Another question. So can we hack around the camera feed, for example? A lot of people before Meta giving the pass-through access, a lot of people, they just took the cast feed and then processed it to the CV and then sent it back to the headset. So can we do the same with Matter? The same? Not with the WebXR templates, not for the headset templates. Basically, the way the WebXR specification works is that when you're building the content, the camera is rendered kind of out of our hands, if you like, by the browser behind the 3D content that's rendered in front. So we don't even have access to the texture on the GPU for the camera. In other bits of our technology with Mattercraft, we have handheld AR where we're running it in the web browser. And in those cases, we do all of those sorts of tricks. But unfortunately, with WebXR, the camera, I think ultimately for privacy reasons, is not accessible to us. But we have been active in the WebXR specification group to try and get better access to the camera with, of course, the user's permission.
Do you have the spatial data?
You have broad tracking spatial data. So the poses, I think maybe even planes. I'm not sure if that's implemented in the Quest browser, but also the controllers and what have you. Nothing more computer vision level, so we don't get feature points or anything like that, but we get tracking data.
Okay, thank you.
No worries.
Hi. So I want to ask you about how do you implement multiplier experiences? Is it possible?
Yeah, it definitely is possible. We don't provide any primitives inside Mattercraft for that, but Peer.js, for example, is a project that you could integrate with Mattercraft. And if you're happy to do the scripting, basically have a message channel and synchronize whatever state you want between the different players. So it's possible, yes, for sure.
Okay, and the second question is, can multiple people edit it at the same time in this?
Yes, absolutely. So if you're using a cloud-hosted project, so like this one is here, where if you go to zap.works, just on the slides which we'll provide kind of show you how to go in there, then you can have multiple people working concurrently in the same project. So if George was here collaborating with me, I'd see like his little symbol next to the files that he was working on. That works pretty well, but in the nature of a project, especially when you start scripting, I would recommend using more traditional revision control, something like Git or Mercurial or something like that, just so that you're not stepping on each other's toes. Like if George is scripting the dance floor while I'm trying to work in here, he's going to be adding like syntax errors to the script as he's writing it. And so the dance floor is going to be like, oh, I work. No, I don't work. No, I work. So it works if you're communicating well and you're separate, but otherwise just use Git and the usual mechanisms, for example, that you would collaborate with Unity.
Actually, I also want to ask a question. Thank you for your presentation.
You're welcome.
And I saw it on a demo, and the user can see the changes in the rendering instantly after you did in the editor. But sometimes the 3D models, they are very huge and very big. They can't be loaded instantly. And maybe the operation will perform not that fluent. So what's your motivation to do for this feature?
Yeah, absolutely. Well, the main motivation for us is that there are a set of changes when you're building an immersive experience where immediate feedback is very helpful. So when you're trying to size something in particular, or you're trying to get an animation to feel right and see how it plays in space around you. And so our motivation is basically, let's try and make it really easy to iterate so you can make that change and view it very quickly. Mattercraft has this built-in bundler that's constantly taking all of your assets and all of your script and making that into this compiled version that your phone is then, or your headset, I should say, is then showing to you. And there's a variety of different times on how long changes will take to go through that bundler. A given property being changed on one of these nodes will happen instantly or within a small number of milliseconds. If you add a new 3D model, as you say, it has to get passed over the network to the device. And so it might take a second or two for that change to appear. In general, the expectation I think you should have for that feature is that it's faster than a typical web development bundler, but that your nature is that you're working with big assets sometimes. And so, yeah, just optimize your 3D models and you'll have the best time.
And some use cases need really precise tracking systems, like outside-in tracking systems or something. And does Mattercraft also support such hardware or headset with outside-in tracking?
Absolutely. With Mattercraft in headsets, with the WebXR specification, we are using the tracking provided by the headset hardware. So it's exactly the same quality of tracking that the Quest provides in all Quest experiences. So it's the same expectation for tracking in Mattercraft as you would have with a Unity experience or any other Quest-based experience.
So my question is it possible to fetch the environment mesh from, for example, Quest and use it so that the object can interact with the environment? And the other question is if people need to sign up to be able to use the links I send them, or can I use them anonymously?
Yeah, when you publish a project in Mattercraft, it's a link. Nobody needs to log in or sign up or anything like that. Basically, all we provide is static website hosting. That's all our publishing system basically is. So whenever you build and compile your project in Mattercraft, the web link is just a URL that anybody can put into their browser, no login or anything like that. I've answered the second question first, which is a silly thing to do because now I've forgotten the first question. Sorry.
Yeah, it was about if I can take the environment mesh and bring it into my environment.
Yes, I don't think that the WebXR specification provides that on Quest. But we should check because there has been a major version update. We'll check.
I have two questions as well. one question regarding to self-hosting. I love to host that stuff on my Raspberry at home. Second question, the Safari browser is not really WebXR friendly, how you get around the tracking stuff. Really stable tracking in the web browser. Self-hosting and tracking.
Yeah, no worries. Cool. Okay. I'm going to answer the last question first again, which is the mistake I made last time. But Safari, yes, doesn't support the WebXR specification. But at Zapper, our company, we have our history is actually in computer vision. And we built Mattercraft because we needed great ways of building content on top of our computer vision. So we have at Zapper a high frame rate, high performance world tracking implementation for the web that we run in WebAssembly and runs on iOS and on Android, just in the native web browsers. It's pretty good, but if you need even better quality tracking than that, and you're doing a handheld AR experience through, like on iPhone, we also provide this app clip that basically it's like a mini app that you don't have to install on your phone. Whenever the user scans the QR code, the operating system will automatically download the little mini app and show the experience. And we provide an app clip that is basically just a normal web page, but we take the computer vision and we offload it to ARKit. So you get the benefit of like high quality, or that you get the benefit of the ease of web development and deployment, but with the benefit of the high quality tracking. Nice. Then on self-hosting, you can absolutely self-host content built by Mattercraft. There's a button down here for downloading a publish output. If you use our computer vision, so you're like, let's say, doing a handheld experience rather than WebXR, then that's licensed separately from us at Zapper, and so we give you a license for self-hosting in that case. But I think if you're doing WebXR stuff with the headsets, for example, I think you can just hit that download publish output button and put it on your server, on your Raspberry Pi. Well, thank you very much, everyone. If you do want to give it a try, please do, and we're here to help. Like, we're the people that make it, along with the team at Zapper, so we're the people that you need to speak to if you have any issues or questions or challenges, in addition to the AI assistant. So yeah, let us know how you get on. All right.